So here we are, tips and tricks. This is our seventh edition. So it's always fun and hopefully a learning experience. Definitely for us, we learn as we go through the examples, but even more so as we address your questions in the latter part of the program. So without further ado, we're going to have our distinguished course assistants, Caitlin and Riley, take you through a few examples and give some tips from their own distinguished experience as members of the class not too long back. So, great.
Okay, just give me 1 second. It should be good, right?
Yeah, that's super. Super.
Okay, perfect. All right.
All right, so we kind of made the example similar to what you're going to see on Lab 6. And the first question you're going to see in Lab 6 utilizes like rolling a dice. It's like stuff like Dungeons and Dragons. And some people might not be familiar with what a modifier is, which is something that you use in Dungeons and Dragons. And so yeah, we're just showing here using NP arrange function to make a dice that is 6-sided, and we're adding a modifier of 2. We just define that here, and then we added the modifier onto our previous range that we made for the 6-sided dice. And as we can see now, every number is going to be like 2 more than it was. So 1 turns into 3, etc. So yeah, that's how the modifier is utilized. A lot of people get tripped up on what it means, but it's very simple. It means you're just adding to whatever. Yeah, you're gonna be adding that onto the dice in the lab. And then here we're utilizing the function np random dot choice on our roll options, and this is just going to print out a random number. So we have only 6 options here, but in the lab you'll have more, and it printed out 4. And here we can use the np dot random choice to get the dice with a modifier. So this will make your average higher because you have the modifier on it. So as we can see, this one says 4, but this one says 5, and you're more likely to get a higher number with the modifier just because it's more, it's your roll is worth more. So we can use the min function here to get the minimum estimate of what your roll will be, which is cool. That's a good function to utilize. Can also get the maximum by writing max in the same kind of format. Here, rolling a die multiple times and finding the average roll, we can do that by using np random dot choice, and then we can do our roll 10 rolls, just comma dot 10. But the more rolls you do, the better. There's a question where it asks you to roll it 100 times. Just make sure you're reading the lab very carefully, making sure you are paying attention to how many times it wants you to run the dice rolling. And then we can get the mean by using np.mean. Yeah, some stuff you'll be seeing in lab 6 along those lines.
Okay, and I'll do the second part. So another thing you'll be seeing is a variety of sequences in the actual lab. It'll be base pairs, so your ATGC. In this case, we just used ABCD. It's a little simpler. So this is just one of our examples for a random sequence. You can see basically a mix of the letters A, B, C, and D, if that wasn't obvious. And then just as an example of a substring, basically taking a portion of the sequence and cutting it down to only a certain number of characters. So that's where you'll see it goes from 0 to 4 characters. So the first 4 on the list. So when I print that out, you'll see A, B, C, D, which lines up the first 4. And then this way you can also count how many times a particular character appears within that substring as well. So we took our substring that's A, B, C, D, and we just did count B, so it'll count how many times B appears within that substring. So obviously we'll see 1 because it appears 1 time. And then we'll see another example. We did 8 characters instead, so it's a little longer. And we'll count B again, and you'll see it 3 times, so that should line up. Yep. So it's here, here, and here. So that's how you would count how many times B appears within the substring. And you could also count how many times it appears within the initial sequence as well, depending on what question it's asking. And then also another thing I wanted to mention in terms of the lab is the dictionary. So a dictionary, and I wrote the definition up here just so you could see. It basically stores values in pairs. So the first value is a key. It's usually just in letter format, and then it would be comma the value. So it's usually a numerical value. So you'll see that in the example down here, in our dictionary example. So you can see the letter value, and then which is our key, and then the number value, which is our value. So that just has a list of keys and values basically. So here you'll see we picked out the keys in this example. So you'll just see these. And then when you pick out the values independently, you'll just see the numbers. So that way you can see which is which in the example. And then I brought back an old lab for an example, our favorite, the pizza example. So I made a dictionary using those. So the keys being the name of the slice, like the type of slice, so cheese, veggie, pepperoni supreme, and then the value being the price or the cost of the pizza slice. So I'll run that. And then this way, selecting a particular key, we can pick out which value is associated with that key by doing the .get. So when you do that, it picks out the number. So we did .get veggie within our pizza example. So it'll pick out whichever number is associated with that key. And you'll see down here it matches and it says 12. That's all I really want to say for dictionary. If that doesn't make sense, obviously feel free to ask questions, but I do want to just list a few reminders as well. Just noticing throughout these past few weeks. Obviously read the questions carefully, with what Riley mentioned, with that 100, rolling 100 times. Sometimes those small little things will make all the difference when you're answering these questions. Double check your spelling, because obviously one letter or one uppercase, lowercase, one punctuation mark makes all the difference. It won't read your coding if it's not exact. Reference your old labs. So obviously we're kind of reusing the same stuff we've been using throughout the whole semester. So don't be afraid to go and look at your old labs for help in case there's something you're like, oh, I remember doing this, but I don't remember exactly how it was formatted. So just make sure to go back and reference your old labs because they can be very helpful. And then if you're stuck on a question for too long, at that point, my best suggestion is just to like take a break, look away from it for a little bit, because maybe you're just staring at it for too long. You need like a fresh set of eyes and look at it later, or obviously ask for help. You can ask, the course assistants, professors, or
I knew you were
even
here because I heard you put it.
other students as well. So, even a different set of eyes can make all the difference. If there's an error and you're not seeing it, someone else might, can make all the difference. And then lastly, make sure everything has run properly before you're running a new cell. So sometimes I've noticed people will forget to run this at the very beginning, like the import numpy, all that stuff, or they've reloaded the lab for like a second or third time and they forget to rerun it. So nothing runs underneath it. So just make sure you're hitting that run all button or run all above the selected cell you're working on so that everything runs properly. In case there's any errors, it could be from that. I've seen that a few different times. But other than that, good luck. And, if you have any questions, feel free to ask. We are here. Good.
That was super. So concise and wonderfully sort of interleaved between the two of you, talking about the different parts. So that's great. I think those are extremely helpful tips and a few tricks, pointers. So I would take to heart what Caitlin said at the end in terms of following all those pieces of advice. So a quick question that came to mind for me, which, well, students might not be deep into six yet, but it will begin to show up. If they took the mean of a large number of six-sided rolls, I think I noticed in your example you got 3.29. What would you expect if you took, for instance, 100 or 200 or 300 rolls?
You would have like
Or
a
you can,
higher likelihood of getting a different numbers. Like if you only roll like 3 times, the likelihood of getting when you're rolling like a 21-sided dice, the likelihood of getting
right,
a certain number is less just because of the odds of rolling it so many times.
right, right. Yeah, so it won't be evenly distributed. Exactly. So that was the point, yeah, you were getting to. And I think the other thing is like with the six-sided die, the mean that we might expect ultimately is 3.5. So if, for instance, we got 4.5 as the mean, or 4.4, we might start to think that the modifier might be 1, because if we keep getting 4.5 or so, it indicates that the mean that we're observing is 1 greater than the mean that we would expect from a six-sided die.